Section 6.1 is radian and degree measure of angles. So an angle is basically what we call two rays with the same initial point, and there is an initial side and a terminal side of the angle. And this, of course, depends on how you're measuring it. You start at the initial side and end at the terminal side. Okay, so this gives us positive and negative angles. So the angle theta is positive when its measurement from the initial side to the terminal side is counterclockwise. And it's going to be, the angle theta will be negative when the angle is measured clockwise. That is, going from the initial side to the terminal side clockwise is negative. So the one I've showed here in my illustration here is a negative angle. So my theta sub 1 is negative because I'm measuring it clockwise. Now if I made this green one side, if I made this the initial side and this the terminal side, then it would be positive. So the angle depends on how you're measuring it. And that might seem unusual to those of you who are used to like measuring angles and triangles and such, where the angle is always positive. But we do this for a reason. We can make functions where the input is the angle, and we can let the angle be any real number if we allow negative numbers. And so it just makes it easier to deal with the properties of these functions, what we call the trigonometric functions, or trig functions for short. If we have positive and negative inputs, that is theta, positive or negative, it makes the properties a little easier. And you'll see why we want them to be easier, because you'll see it gets fairly complicated and you don't want it to make it harder than necessary. Okay, so this one here, this angle, I'm measuring the initial side, same initial side, same terminal side, but I'm measuring it counterclockwise. So that angle measured counterclockwise like this is a positive angle. Just going counterclockwise, positive. Okay, this is called the unit circle. When we say the unit circle, we mean the circle with center at the origin, 0, 0, and with radius 1. Unit means 1. So we don't mean a radius 1 circle somewhere else. We mean with the center at the origin. So it's kind of the simplest circle in Cartesian coordinates. Okay, standard position for an angle has the initial side of the angle on the positive horizontal axis. So I'm calling that the C-axis here. I have a C-axis and S-axis. Your book probably calls it X and Y-axis. There's a reason I'm calling it the C and S axes, and you'll see why. Of course, we could call them anything we wanted to, but calling them C and S helps us later, and helps us because later we'll have two different planes with two different X's, and people get the X's mixed up. That's one reason for the C and the S. And the other is they correspond to the names of certain trigonometric functions. Okay, so standard position, the initial side of the angle is on the positive horizontal axis. So that yellow initial side there always points to the right. And then the terminal side falls wherever it falls. Okay, so, but the endpoints of our two rays is going to be at the origin here to be in standard position. Usually if an angle isn't in standard position, we put it in standard position in order to compute things. Okay, the vertex of the angle. So the vertex of the angle is this point here, where the two endpoints of the rays meet. That's the vertex of the angle, and it's at 0, 0. You might notice I color code these. The first coordinate is orange. That's the C-axis, and the second one is red. That's the S-axis. If you're colorblind or something, they're just different. This one's lighter color than this one. If you have difficulty seeing this red S, let me know, because that means I'll have to change the background. Some people with color blindness can't see. I know red on black is really, really bad. Okay, so standard position, terminal side, initial side, unit circle, right? And how do we measure the angles? When are they positive and when are they negative?